second speaker is Alexander Bouchet.
Buchemski. Thank you so much. Great. So I just want to thank the selection committee at the Connecticut Junior Science and Humanities Symposium for giving me this opportunity to share my research with you all today. So specifically, I studied UVB-induced Sorlin photoactics and their rapid detection with surface-enhanced laser desorption ionization, time-of-flight mass spectrometry, otherwise abbreviated as CELVTOF. So the first thing I want to address for you today is what is Sorlin? Well, Sorlins are compounds that occur naturally. So you find them in plants like Amimagis, for example, which is actually a common folklore medicine used actually in ancient India, back in the Ayurvedic medicine. But you also find it in more common plants like limeskin and celery, and that is fungicides. But chemically speaking, this is the structure of the sorlin molecule right here. It's an aromatic compound, and it forms part of the class of linear fluorocoumarines. And the actual linearity and planar structure of the molecule gives it an important characteristic and will allow it to both absorb energy and interact very interestingly with other biological constituents. So a major discovery came in 1955 by Mosiah, and essentially he characterized sorlin's interactions with DNA. So sorlins have a natural affinity for actually adenine and thymine sites in the DNA sequence. And they migrate, and the thin structure of the sorlin molecule allows it to slide right in between the DNA base pairs. And this is known as intercalation. Now, interestingly, when sorlins are irradiated with ultraviolet light, the molecule becomes excited and a covalent addition occurs between it and an adjacent thymine base. Okay? And this is known as a monoatom. And just before I proceed, that monoatom can also occur on the other side of the sorlin molecule as well. So there are two types of monoatoms. And if another photon excites the monoatom species, another covalent addition occurs on the other end, and a crosslink is formed. And Mosiah showed that these crosslinks hinder DNA replication because the polymerases that unwind the DNA simply can't bypass these atoms. And as a result, you can actually show that sorlins generate apoptosis. So on the molecular structure, it's actually the 4', 5' bond of the sorlin that is excited first, generally believed, to bond to a thymine base. This is a 4', 5' monoatom. And then, again, a second photon will excite the 3', 4 bond to generate the crosslink. And this will also be explained in the context of my results, but I just wanted to show you molecularly. So how have sorlins been used traditionally in clinical applications? Well, they've been used a lot in dermatology to treat conditions like vitiligo and psoriasis. And I've dubbed these